Hello, my name is Nur Adlina binti Hamdan. I will brief to you the abstract of the soldering. Soldering is mainly used in every manufacturing part that we know surround us. Starting from 5,000 years ago, soldering has been evolved around us from joining other part of metal in bigger part of to soldering small compartment in motherboard that create a strong permanent connection part. As we look back from the history of soldering technique only be done heating up any part of metal or wire until it reach its melting point so then it can be joined together. This technique only requires open flame which can only be done for big mechanical part. Invention of electricity makes soldering can be used in any part of invention as long as we have device for soldering that can operate on electric current. Our aim is to see how soldering function based on the type of soldering technique we have and how we determine to choose which technique is the correct for our application. Based on the study from a few articles that we found for soldering technique in engineeringchoice.com, we can conclude the finding on which particular flux and technique that can be implemented in our manufacturing process based on the durability and purpose for our invention. Hello, we meet again. So here we go for introduction. First, soldering is a process of joining other parts together to create a permanent connection by melting electronic part with solder. Solder is a fusible metal alloy used to create a permanent bond between metal workpieces. The solder is melted in order to adhere and connect the pieces after cooling, which requires a suitable alloy for use, as the solder has a lower melting point than the pieces being joined. Second, soldering also can be reversed by using desoldering tool to serve the connection that has been made. In contrast to welding, the workpieces are not melt when soldering. Brazing also doesn't melt the metal of the workpiece, but the filler metal melts at a higher temperature than soldering. Historically, all solders contain lead, but environmental and health concerns have increasingly detected the use of lead-free alloys for electronics and plumbing purposes. Third, solder is a metal alloy that originally a mixture of tin and lead that is melted with hot iron to form a bond between different types of metal compartments. Filler metals used in soldering used to be lead-based. Due to regulations, lead-containing solders are increasingly being replaced by lead-free solders, which can consist of antimony, bismuth, brass, copper, indium, tin, or silver. Last but not least, there are three different types of solder. First, we have lead-based solder. Second, we have lead-free solder. And the last, we have flux core solder.
Assalamualaikum and hi everyone. My name is Ahmad Azamuddin bin Muhammad Yazid from class 5B2. For this presentation, I need to present about literature review on topic soldering process. For literature review, I want to talk about 5 points which are working principle, factor involved in soldering process, soldering method, application and process parameters. For the first is a working principle of soldering process. Firstly, soldering gun must be heated up to desired temperature, and then the filler metal should be contact to the soldering gun to melt the filler metal and allow filler metal flow to the work region. Then melting temperature of filler metal must be lower than 550 degrees Celsius. And then the surfaces to be soldered must clean first to allow the solder flow, and then an appropriate flux must be applied to varying surfaces, and surfaces are heated. And lastly, filler metal cold solder is added to the joint which distribute between the closely fitted surfaces. Next point is factor involved in soldering process. There are three factors involved, which are wetting, alloying and spreading, capillary action and filling the joint. For wetting factors, basically wetting is a property of liquid by which it spreads over a solid surface. Flux or solder must spread over the base surface being joined. If a solder does not wet a surface, so that there is no bonding between solder and base metal. The solder that spread out and wets the base metal will produce sound joint between the two surfaces and can be removed only by scraping or fillings. Next, alloying and spreading. The ability of solder to alloy with the base metal is related to its ability of wetting the surface. Alloying is related to the cleanliness of base metal. Must be contact between solder and the base metal in order to alloying occur at the interface. In order to achieve this contact, cleaning and using a flux must do first to remove the oxide film from the surface of the base metal to be joined. And lastly, capillary action and filling the joint. The manner in which solder will fill the space between two metal surfaces influences its joint filling capacity and the degree to which the surface imperfections are filled. The fluidity of molten solder must be sure enough in order to flow to narrow spaces by using capillary action. The main factors influence the effectiveness of joint filling include the wetting angle between solder and base metal, clearance of gap between the two surfaces to be joined, heating rate and its uniformity, temperature, nature of solder use and use of the flux. So the next point is soldering method. There are three methods which are hand soldering, wave soldering, reflow solderings. For hand soldering is a manually operated soldering gun and it is easiest and most common soldering method in electrical engineering. For wave soldering is a soldering of multiple lead wires in printed circuit cards. This soldering is through a liquid wave formed as a result of motor agitation, and the liquid is actually dissolved tins. As you can see picture on the left side, the grey region is a solder wave, is a called solder wave, which is each movement is in a solder form, is in wave forms, and the right side is a wave soldering machine. And next, reflow soldering methods. It is used to surface mount component on printed circuit card SMT component PCBs. It's a permanently glued component that are first temporarily stuck to their pads on circuit board through solder paste that will be met through hot air or other thermal radiation conductions. In the picture left side, we can see the flow of hot air which is circulate in this machine, which is important to melting the solder. And the picture on the right side is a reflow soldering machine, or also known as reflow oven. And the next point is applications. For the plumbing industry, soldering used to seal liquid leaks or repair radiator cores. Next, soldering a copper water supply line, and also to join the pipe and fitting in order to fit the gap between the joint is filled with molten metals. For electronics industry, soldering used on printed circuit board PCB. Solder on PCB is connective metal alloy that acts as the electromechanical connections that connects the component to substrate and brings electrical continuity to the circuit board. And the lastly application is metalworks. Soldering can also be used in metalworking and used to make and repair jewelry and musical instruments. And it also used to join between the steam sheet metal. So these are a few images of applications. For the first one, we apply to join between thin sheet metal. And next, for this, to join the copper pipe to the T joint. And next, solder on PCB board. And lastly is delta soldering. So the lastly is a process parameter. So this is a few parameters and its own units that used in soldering process.
Salutations and salam UiTM di hatiku. My name is Hewitt Irai and my student ID is 2020-483-816. For today, I would like to elaborate on the effects of the parameter involved in soldering. Now, first and foremost, I would like to thank you, Daniel Tartaglia, for this wonderful YouTube video which is on the topic of 10 stupid errors to avoid in solderings and also the tips. From here, we can see that the video shows the do's and don'ts whenever you are doing the soldering. Now, for this video, we have taken it for reference as it shows how it can affect the parameter involved in soldering. Now, as for the important parameter for our soldering, it includes the soldering conditions, the selection of the material, the technique, and also the temperature. Moving on to the soldering iron. Soldering iron is one of the main components when doing soldering. Just make sure the tip of the soldering iron is always free from any fluxes, or make sure it is free from any oxidized particle. From here, we can see that one of the special tools that we needed to use in order for them to keep it clean is by using a special abrasive sponge. Another thing is that you can use a wet sponge, and last but not least is that you can also use the special abrasive sponge to clean off the oxidized particle. Whenever you are doing this, it is actually to improve and to increase the effectiveness of the soldering that you are wanting to do. Now, moving on to number 2. Number 2 is whereby the selections which plays a very important role. As for you want the correct size for the tip, for the fluxes, and also for the soldering iron tip to be at the correct corresponding sizes. Therefore, you can avoid any type of unwanted sizes and a very bad incident to happen because of the excessive amount of the fluxes needed for a soldering. Now, moving on to the next part is the technique. Now, here is something that people had been trained for many months, for many years in order for them to conduct the soldering process. From here, you must always be reminded that whenever you want to do a good product of the soldering, you must always put some of the tin on top of the soldering iron for the conductivity, as it will act as a thermal conductivity. From here also, you must also put some soldering between two elements which are also counted as a pre-tinning for the surface of the copper wire and onto the tip of the soldering wire. Hereby, you can actually make sure that the fluxes of the soldering are spread evenly throughout the soldering material. Now, last but not least, one of the things that might affect the parameters of the soldering is that the temperature. Now, the temperature plays an important role as it only limits to below 450 degrees. Now, from here you can see that whenever you are using the correct temperature, it will result to a very good soldering. However, when you are using too high of it, it might actually incidentally hurt the user, and it might also break and damage the material or the components that you are soldering on. So these are all of the important parameters that are needed to be included whenever you are doing the soldering.
Performance of soldering. A lot of characteristics can be identified by doing this soldering. So how to identify if it's a good soldering? A good solder joint shows this characteristic: smooth, bright, shiny, clean, concave solder fillet, good wetting, the end of the wire or lead is covered with solder. Secondly, to have a good performance of soldering, avoid to have an incorrect solder type. For example, electronic solder for mechanical joint or vice versa. That will lead to a weak joint. Third, the last thing we should avoid is defects. Soldering defects in electronic can lead to a short circuit, high resistance in the joint, intermittent connections, component overheating, and damaged circuit boards. Flux left around integrated circuit leads will lead to interlead leakage. So what is the advantage of soldering? So this is the answer. Low power is required, low process temperature, microstructure is not affected by heat, easily automated process, dissimilar materials may be joined, high variety of materials may be joined. Disadvantages of soldering. Okay, first is large section cannot be joined. Second, fluxes may be contain toxic components. Third, soldering joints cannot be used in high temperature application. Fourth, low strength of joints. Fifth, careful removal of the flux residual
is required in order to prevent corrosion.